Well, another set of emails that I get is reactions to my book, The Future of Humanity, which hit the New York Times bestseller list. And it talks about how space travel may progress, not just in the next century, but perhaps maybe in the next 1,000 years. Perhaps one day we'll have interstellar drive. Perhaps one day we'll be able to leave the solar system and terraform Mars and other distant planets and become really a spacefaring civilization. Well, that's a hope, and that's still science fiction. But in my book, The Future of Humanity, I give interviews with the scientists who've done the math. They've done the physics, and they believe that, yes, one day, we don't know when, one day perhaps humanity could be a spacefaring civilization. Well, I get some emails that say, well, come on, give me a break. I mean, after all, take a look at the Apollo space program. We went to the moon, lost interest, and never went back. And so maybe we're going to have another space race like that, where we have all sorts of gizmos being sent to the moon, and then we lose interest. Well, that's a possibility. But in my book, I lay out the reasons why the first era of space exploration never really went anywhere. And that's because of a four-letter word, cost, C-O-S-T. Back in 1966, it turns out that the budget for the Apollo space program was 5% of the entire federal budget. Now, that's amazing. 5% of every dollar you paid in taxes back in 1966 went into the moon program. Well, obviously, that is not sustainable. And it was not an accident that once we went to the moon and beat the Russians, well, we did what we claimed that we were going to do, and we lost interest. It was too expensive, and we accomplished our main goal of beating the Russians. Well, now we have a whole new set of players, not astronauts, but Silicon Valley billionaires who are footing the bill for a new generation of rockets. They are not bound by the bureaucracy of NASA. You don't have lumbering bureaucrats looking over your budget. No, you have Silicon Valley billionaires that are opening up their checkbooks, paying for a new generation of rockets. For example, back in February, millions of people tuned in to the launch of the Falcon Heavy rocket in Cape Canaveral, paid for by a private individual, Elon Musk, the billionaire behind SpaceX. Now, why did thousands of people line up the streets of Cape Canaveral to watch the launching? Why did millions tune in online? After all, it's just another rocket, right? Well, that was a moon rocket. And that's what excited the imagination of millions of people around the world. For the first time in 50 years, a moon rocket was launched from Cape Canaveral, funded not by taxpayers, funded by the checkbook of a private individual, Elon Musk. And we now have the possibility of not one, not two, but three moon rockets that'll take us to the moon. One, NASA is fielding the SLS booster rocket. It has its own manufacturers, including Boeing and Lockheed, behind the SLS booster rocket. And it's going to be fired up in the end of 2019. And we're going to go back to the moon with an unmanned mission in 2019. A few years later, NASA is going to send astronauts back to the moon. Not to be done, Elon Musk is firing up his Falcon Heavy, and he wants to go to the moon as well. And then we have Jeff Bezos, the richest man in the world, founder of Amazon.com, funding his own spaceport in Texas. Get this, he doesn't have to go to Cape Canaveral. He has his own spaceport funded by private funds in Texas, and he has what is called the Blue Origin program. First of all, we have the New Shepard rocket, a rocket that simply goes into outer space and comes back down and brings tourists to the edge of outer space. Then we have the new Armstrong rocket, still on the drawing board. That'll take astronauts all the way to the moon. So we have not one, not two, but three moon rockets that are being funded by taxpayers and by private individuals. So the cost of space travel, you can imagine, has dropped considerably since the 1960s. In fact, perhaps you saw the movie The Martian, starring Matt Damon. That movie cost $100 million. Realize that actually going to Mars, the Indians put a space probe around Mars for $70 million. So believe it or not, it costs more for Hollywood to make a movie about going to Mars than actually going to Mars. And then the rockets of Jeff Bezos and Elon Musk are reusable. And that's going to change the economics of space travel once again. After World War II, we had all these GIs that came back from the war flat broke, couldn't afford a car. But the used car market in the post-war era changed American culture. Rock and roll and used cars. That became the lifestyle of American teenagers. So the used car market today is bigger than the new car market. That's how big it is. And so we think that the used rocket industry would eventually be bigger than the original rocket industry itself. And that's going to reduce the cost. And then, of course, people have their sights on the moon. As President Donald Trump has stated, first we go to the moon, then to Mars, and beyond, meaning perhaps after that, the asteroid belt. Now, the moon, of course, is only 3 days away. Mars is perhaps 2 years away, and it's going to take a lot of money and a lot of gumption to go to Mars. A 2-year mission to Mars, perhaps 9 months to actually get there, and then several months to do experiments and wait for the launch window to return, and another 9 months to return back to the planet Earth. When's that going to happen? Perhaps in the 2030s. Perhaps that is the decade when we go to Mars. And then what do we do on Mars? It'll perhaps be done in phases. It won't be done at all at once. Initially, the first astronauts will build a base, perhaps use solar reflectors and solar panels to gain energy, perhaps use a lava tube as a temporary base for operations. Then mining operations are next on the agenda. Water, for example, in the form of ice can be mined and heated up for drinking water. Also, you can separate out oxygen and hydrogen and create rocket fuel for a mission to Mars. And then after that, perhaps a permanent moon base can be constructed using Martian soil. It turns out that on the Earth, we can duplicate the chemistry of Martian soil. And we know that heated up with, let's say, microwave radiation, you can actually melt it and create brick made out of the sand of Mars, and begins to build structures on Mars. And then longer term, perhaps orbit Mars with satellites, solar satellites that can beam energy down to the ice caps of Mars. If you can raise the temperature of Mars by 6 degrees, then you have a runaway greenhouse effect. The more sunlight you add to Mars, the more water vapor you create, which means that rivers will flow once again on the surface of Mars. And then that means more greenhouse gases will be captured, and that means an even larger increase in temperature. So an artificial greenhouse effect may allow you to terraform Mars. Now, of course, this is not going to happen anytime soon, and it does mean that, of course, it's going to cost money. And that's why some people have said, from Google in fact, that they would like to set up mining operations on the asteroid belt. One asteroid brought down from outer space could bring back perhaps $1 trillion in platinum-based chemicals and also in rare earth elements. And so perhaps the space program could literally pay for itself. Well, if you want to find more about the pros and cons, the dangers and the promise of this technology, get a copy of my latest book, The Future of Humanity, because scientists have done the math. They've worked out the details. What it takes, of course, is money, resources, and a lot of gumption to begin the process of colonizing the universe. And another set of questions that I get by email concerns robots. Recently, there have been a lot of TV specials about artificial intelligence. For example, you've probably seen the show where waiters and cooks can, in fact, be automated. In fact, in Japan, there's actually a restaurant which is fully automated. The waiters that come up to you taking your order are robots. The cook is a robot. In fact, can make noodles in 1 minute and 29 seconds without missing a beat. And so the question is, well, which jobs are going to survive and which jobs are going to be obliterated by the computer revolution? Well, I've actually written several books mentioning this. If you look at my book, The Physics of the Future, I have a whole chapter about what jobs to avoid and what jobs could flourish in the future. First of all, we forget that robots are adding machines. They add millions of times faster than us, giving us the illusion that they are thinking, but they're not thinking at all. They're nothing but very sophisticated adding machines. But that means that repetitive jobs are doomed. Repetitive jobs that can be replaced probably will be replaced in the future. And that means that the jobs of the future will be those jobs that cannot be done by machines. And then the $64,000 question is, what are those jobs? What are those jobs that robots cannot do? First of all, we have a huge class of tasks that cannot be done by robots that involve human relations. Lawyers will have jobs, for example, because lawyers have to argue to a jury of humans, not robots. The Constitution, of course, laws guarantee trial by your peers. And robots are therefore not going to be robot lawyers arguing to a human judge and a human jury. Humans will do that. Paralegals, however, could be endangered because paralegals are search engines, searching through volumes of books looking for precedents. And so a lot of that busy work in a law firm could be done by robots. However, the actual work of talking to people will be done by humans. And then people ask me a question, what about you, Professor Smarty Pants? Is your job going to be automated? Well, yes and no. First of all, we have e-courses on the web. Stanford, MIT have pioneered these courses, but they don't tell you that the dropout rate for some of their advanced courses approaches 90%. That's right, some poor kid in Pakistan gets energized to sign up for a course at Stanford, thinking that they're going to be at the cutting edge of artificial intelligence, and then they get discouraged. Then there's no one to talk to, no one to grade their homework assignment, no one to give them career guidance, and they drop out. And that's where professors of the future will come in. Professors of the future will be more like mentors. They're not going to be professors giving the lecture so much. That'll be done by master professors on the internet. However, somebody has to grade the papers. Somebody has to hold the student's hand. Somebody has to encourage them and give them a career path suited for their needs and suited for their abilities. Robots can't do any of that. And so it means that for a long time, we will still have professors the old-fashioned way using e-courses, but still grading homework assignments and encouraging students. So those jobs are going to be there in the future. Another class of jobs is semi-skilled jobs that are non-repetitive. For example, garbage men, sanitation workers, picking up garbage. Picking up garbage is one thing that's way beyond the ability of robots. Also designing a garden, being a carpenter, fixing a toilet. These are non-repetitive jobs that cannot be done by any known robot. So semi-skilled jobs that are non-repetitive, like cleaning up garbage, like being police, by being construction workers, those jobs are going to survive. And then creative jobs will survive because robots can copy art, but robots cannot make art very well at all. So jobs that are creative, writing a novel, creating beautiful works of art, those jobs will survive because robots are not very creative. They're not very innovative. However, let's say in a hospital, certain jobs will be automated. For example, the X-ray technician that analyzes scores of X-rays. That can be done by robots. Robots are very good at looking at raw data, huge mountains of boring data, and searching for regularities and patterns. And so one type of job that could be endangered are those jobs that simply look at X-rays and determine whether or not you have cancer, or look at brain scans and looking at whether or not you might have Alzheimer's disease. Those jobs can be replaced. However, the actual job of making the final diagnosis probably will be done by a human because humans have experience. Robots simply look for patterns. They may miss the obvious because robots do not have common sense. And that's where humans are going to be in the loop. Any job that requires simple, ordinary common sense will not be done by robots. In fact, if you try to catalog all the rules of common sense, even a 4-year-old child knows common sense better than our most advanced robot. For example, water is wet and not dry. Well, robots don't know that. Why can't liquid be dry? Robots have not encountered this, and so they have no programming that tells them that water is wet and not dry. Or mothers are older than their daughters. Well, that's just common sense, right? Any idiot knows that. Well, robots don't know that. Why should mothers and daughters age at the same rate? In fact, according to Einstein, they don't have to age at the same rate at all. Mothers can be much younger than their daughters if they're sent into a rocket ship and time slows down in that rocket ship. And so simple lines of common sense. Jobs involving common sense cannot be done by robots. And so what does that mean for the average worker? What it means for the average worker is they're going to have to be educated. There's going to have to be a new program to educate workers so that they can prepare for the jobs of the future. And what about automobile workers? Well, personally, I think that the robotics industry will be bigger than the automobile industry. The automobile industry today employs thousands of people to repair robots, to repair cars, to monitor cars, to service them, to design them. In the future, your car will become a robot. Your car will be part of the robotics industry. There'll be teams of people designing robots, repairing them, servicing them, monitoring them, keeping track of them. And so think of the automobile industry. The robotics industry will be bigger than the automobile industry of today, which means, of course, more jobs for people, but the level of education is going to have to be higher. Also in the news, there have been more and more UFO sightings. It turns out that we now know that the U.S. government actually had a secret program funded to the tune of tens of millions of dollars to analyze UFO sightings and to take them, well, seriously. However, the study was terminated several years ago. I've looked at a lot of the tapes myself, and I have to admit that you get this creepy feeling that maybe there really is something out there that defies the known laws of physics. Well, first of all, as I mentioned before, I get a lot of email, and quite a few of the emails contain sightings, but if you analyze these sightings very carefully, about 95% of the time, you could dismiss them because of their being natural phenomenon. They could be, for example, radar echoes, the planet Venus, meteors burning up in the atmosphere, weather anomalies. All sorts of things can explain, let's say, 90 to 95% of these sightings. But the last 5% or so are pretty creepy. The last 5% or so seems to indicate that there really could be something out there that seems to defy the known laws of physics. First of all, these sightings show that objects can go quite fast, faster than an ordinary conventional jet. And these objects can maneuver and reappear and disappear on a moment's notice, defying the known laws of aerodynamics. And then people email me and say, well, Professor, what do you think? You're a physicist. Well, let me be honest about this. Most physicists simply shake their heads and they roll their eyes to the sky and they say, come on, give me a break. I mean, after all, the distance between stars is so great. It would take centuries for a spacecraft to reach us, meaning that these are probably just anomalies of some sort that we don't have an explanation for yet. I talked to a skeptic who said, look, he doesn't know what's causing all these funny things on radar screens, but he knows that at some point in the future, somebody will figure it out. And he's one of the past presidents of the Skeptic Society. And his point of view is that, well, he too is clueless as to what could be behind these sightings, but he firmly believes that at some point in the future, somebody will figure it all out. Well, I have my own personal point of view. As a scientist, I have to keep an open mind, no matter how crazy some of these ideas are. Well, who knows? Maybe they could be based in reality. First of all, there is a possible explanation for these sightings. After all, the military does test advanced aircraft. In fact, that's what they're supposed to do, is to push the boundaries of technology to enhance the military. I mean, that's why we pay these generals. One possibility is hypersonic drive. Last March, Vladimir Putin of Russia announced that they have a new weapon in their arsenal, a hypersonic wave device that goes much faster than any supersonic jet. In fact, they ride on an ICBM, they separate from the ICBM, and they're fully maneuverable, meaning that they can evade any Star Wars program. Well, then the United States military was asked about this. If the Russians have something like this, a hypersonic device, then what about us? Well, it turns out that yes, we too have been experimenting with hypersonic drive. However, they are unstable. And that is, we have not been able to successfully maneuver with hypersonic devices. They rapidly spin out of control and they can crash. And so, yes, Russia and the United States are both experimenting with hypersonic drive, and perhaps that could be the origin of some of these sightings. These sightings indicate that there are objects that travel faster than our supersonic jets, can outrace these jets easily, and perhaps they're evidence of hypersonic drive. Then, of course, we have the other possibility that in addition to being experimental devices of Russia and the United States, perhaps they really are visitors from outer space. In which case, I personally think that if that's the case, perhaps they're based on the moon. And that's, of course, the basis of the movie 2001, that perhaps on our moon there is a moon base that is perhaps partially underground and cannot be observed by our probes. And it can't be ruled out that perhaps there is a UFO station not too far from the planet Earth, perhaps based on the moon. In fact, if you think about it, perhaps the most efficient way for an advanced civilization to explore the galaxy containing billions of possible Earth-like planets is to see the galaxy with self-replicating von Neumann probes. And perhaps that's what they are, self-replicating probes on the moon. Why the moon? Because the moon is stable, it has no erosion to speak of, and any alien civilization would see the galaxy with all sorts of robotic probes. So any advanced civilization would see the galaxy using moons as a landing port because they don't have erosion, they don't have water, they don't have wind, and as a consequence, any probe would be stable for millions of years, reporting back to the home base as was done in the movie 2001. That way, you wouldn't have to refuel the device. The device basically is based on a neighboring moon and can use the materials on that moon to manufacture copies of itself. And it would use energy from the sun, and it would be a very cheap way to explore the galaxy. Then these probes would fan out, land on other moons, create copies of themselves, and like a virus, colonize the entire galaxy. So one possibility is that these UFOs, the ones that cannot be easily dismissed, are perhaps experimental hypersonic devices being experimented with by Russia and the United States, as they both admit. Another possibility is that perhaps they really are extraterrestrial, in which case, how do they get the fuel to go between stars? Maybe there's a base based on the moon. It would give close proximity so you wouldn't have to refuel it, and it would provide a listening post whereby an advanced civilization can simply listen in on what's happening in the galaxy. Well, another set of emails that I get is reactions to my book, The Future of Humanity, which hit the New York Times bestseller list. And it talks about how space travel may progress, not just in the next century, but perhaps maybe in the next 1,000 years. Perhaps one day we'll have interstellar drive. Perhaps one day we'll be able to leave the solar system and terraform Mars and other distant planets and become really a spacefaring civilization. Well, that's a hope, and that's still science fiction. But in my book, The Future of Humanity, I give interviews with the scientists who've done the math. They've done the physics, and they believe that, yes, one day, we don't know when, one day perhaps humanity could be a spacefaring civilization. Well, I get some emails that say, well, come on, give me a break. I mean, after all, take a look at the Apollo space program. We went to the moon, lost interest, and never went back. And so maybe we're going to have another space race like that, where we have all sorts of gizmos being sent to the moon, and then we lose interest. Well, that's a possibility. But in my book, I lay out the reasons why the first era of space exploration never really went anywhere. And that's because of a four-letter word, cost, C-O-S-T. Back in 1966, it turns out that the budget for the Apollo space program was 5% of the entire federal budget. Now, that's amazing. 5% of every dollar you paid in taxes back in 1966 went into the moon program. Well, obviously, that is not sustainable. And it was not an accident that once we went to the moon and beat the Russians, well, we did what we claimed that we're going to do, and we lost interest. It was too expensive, and we accomplished our main goal of beating the Russians. Well, now we have a whole new set of players, not astronauts, but Silicon Valley billionaires who are footing the bill for a new generation of rockets. They are not bound by the bureaucracy of NASA. You don't have lumbering bureaucrats looking over your budget. No, you have Silicon Valley billionaires that are opening up their checkbooks, paying for a new generation of rockets. For example, back in February, millions of people tuned in to the launch of the Falcon Heavy rocket in Cape Canaveral, paid for by a private individual, Elon Musk, the billionaire behind SpaceX. Now, why did thousands of people line up the streets of Cape Canaveral to watch the launching? Why did millions tune in online? After all, it's just another rocket, right? Well, that was a moon rocket. And that's what excited the imagination of millions of people around the world. For the first time in 50 years, a moon rocket was launched from Cape Canaveral, funded not by taxpayers, funded by the checkbook of a private individual, Elon Musk. Well, I'm afraid that's it for the first part of exploration. In the second part of exploration, we're going to bring on a computer expert, Ray Kurzweil, to talk to us about the future of robotics, artificial intelligence. Will one day the robots become as smart as us? If so, how are we going to deal with that? Or, for that matter, will one day robots exceed us in intelligence? So once again, with us today is Ray Kurzweil, author of a number of great bestsellers, including The Singularity is Near. And in the second half of Exploration, we're going to bring on inventor Ray Kurzweil, author of a number of bestsellers, including The Age of Spiritual Machines and The Singularity is Near. And his thesis is a controversial one. It's a minority opinion, but it's an opinion that has to be heard. And his claim is that very soon, perhaps by 2020, perhaps very soon, machines will begin to approach human intelligence and perhaps even exceed human intelligence. And even worse than this for humans, robots will be able to create copies of themselves that are even more intelligent than they are. And so they'll be able to bootstrap themselves to become arbitrarily intelligent, in which case they may begin to leave the Earth and begin to colonize the galaxy. That is called the singularity, the point at which we have runaway machines creating machines of even higher intelligence, and the whole process just keeps on going until they, well, take over the universe. Sounds like science fiction? Well, yeah, but it's a position that can't be ruled out. So once again, our special guest in the second half of Exploration is inventor Ray Kurzweil, and we are talking about, well, what happens when the computer revolution goes amok? Mr. Kurzweil, the first question for you is, how did you first get interested in robots and artificial intelligence?
I've actually had in mind being an inventor since I was at the age of 5, and age of 12 I discovered computers. I built some primitive computers myself and got access to one as part of a summer job, and quickly became fascinated with the ability to kind of model the world, albeit primitively at that time, in the computer and create virtual realities, and also model our thinking processes. Quickly became interested actually in pattern recognition, which is my view is the fundamental basis of human intelligence rather than logical, sequential, analytical thinking. And a project I did in high school was to build pattern recognition models of melodies, and I would feed in the melodies of Mozart or Chopin, and it would build a pattern recognition model and then write original melodies in the same style from that model, which were recognizable, kind of sounded like second-rate compositions from a second-rate student of Chopin or Mozart. And that started really a lifelong fascination in pattern recognition, which is really my primary technical field.
Okay, and let's talk about your book, The Age of Spiritual Machines. First of all, what is a spiritual machine? Is that a contradiction in terms?
The primary concept of spirituality is really consciousness. If we consider a being or an entity to be conscious, then we consider it to have spiritual value. And if you look at all the different religious traditions, what they really mean by a soul and by spiritual reality is consciousness, an entity that really has subjective experience and can feel pain and joy, as opposed to just the conventional concept of a machine, which is operating by some kind of automatic process. And we don't worry much today about causing pain and suffering to our computer programs. But our computer software is still millions of times simpler than the human brain. We do find, if we look at the human brain, that we actually can model it with great precision neurons and even substantial clusters of neurons. We can talk more about that. And we will have machines, which is to say non-biological entities, that do have the complexity and richness and depth of the human brain, indeed modeled on the principles of operation of the human brain within a few decades. And when these entities claim to be conscious, to be joyful, fearful, angry, and so on, unlike, let's say, the computer characters in video games today, those entities a few decades from now will be as convincing as humans. They'll have all the subtle emotional cues that we associate with somebody really having those subjective experiences. So are they conscious? Some philosophers will say no, they're not squirting human neurotransmitters. You can't be conscious if you're not biological. But there won't be any clear distinction. We won't be able to separate them from any kind of objective observation. And my prediction, and this is really not a philosophical statement, but a psychological and political prediction, is that the bulk of humans, unenhanced humans, will consider these non-biological entities to be conscious. In any event, they'll be very intelligent. They'll be able to convince us that they're conscious, and they'll get angry at us if we don't believe them. And it'll be an actual political and legal issue as well. In my view, the real issue of consciousness is not something we can resolve scientifically, because science involves third-party objective observation. Consciousness is inherently first-party subjective experience, and there is a gap there. Some people go on to say, well, since it's not scientific, it's not an important question. I would turn that around and say it's really a very fundamental question. It shows that there is a need for philosophy outside of science. But these will become real compelling questions as opposed to just abstract philosophical debate in this 21st century.
Okay, and let's talk about the past first as a guide to the future. Back in the 1950s and 60s, there were dazzling breakthroughs in artificial intelligence theory. We had the first machines, for example, that could play chess and checkers, not very well, but they could at least play the game. They could solve simple algebra theorems. They could even play doctor to a degree and do simple diagnoses. And there were all these fantastic predictions that just within a few years, humans will be put in a zoo. We'll all be zoo animals, and our creations will throw peanuts at us and make us dance behind bars, because look at how fast computers are learning. And then there was the movie 2001. And, well, the year 2001 came and went, and we still do not have the robot Hal, the murderous robot in Arthur C. Clarke's famous movie, that could pilot a spaceship, could play chess, and interact with humans as if it was a human itself. So the question is, what happened to the dream of the 1950s and 60s when everyone was predicting that humans would be obsolete by the 1970s?
Well, your observation is correct. I would say it wasn't everyone predicting that. There were some famous predictions from Simon and Newell at Carnegie Mellon, which came into disrepute. But there was over-optimism because machines were doing adult activities, like solving some unsolved theorems from Russell and Whitehead, and doing these adult activities, playing chess, in some narrow cases making medical diagnoses as well as doctors and so on. So it seemed it wouldn't be long before a computer could do everything. Another 10 years went by, and we realized that computers, while they were able to do these sort of high-level analytic tasks, were not able to do some things that a 4-year-old can do, which is, let's say, tell the difference between a dog and a cat or recognize faces. And this is really a fundamental issue, in my view, that the fundamental basis of human intelligence is not analytic, logical thinking. And in fact, machines can do that a lot better than humans in most cases. The fundamental basis of human intelligence is pattern recognition. We can see that in the contrast with how machines play chess, which is this minimax combinatorial expansion of move, counter moves, which it does largely through brute force. We can look at millions or even hundreds of millions of board positions in a second. Kasparov says he looks at less than one board position in a second, but humans use their tremendous powers of pattern recognition to recognize situations they've thought about before. And we don't think fast enough. Our interneuronal connections compute 200 calculations per second, which is about 10 to 100 million times slower than electronic circuits, but we have 100 trillion of them, all computing simultaneously, self-organizing. Information is really represented as a pattern. No key connection is all that important. It's a very different paradigm from computers we're used to. And it's a very good architecture for recognizing patterns in a profound way. That is really the heart of human intelligence. Now, we have been making steady progress in pattern recognition. I could give many examples of that, both in terms of recognizing language and speech, character recognition, have all improved gradually. Even in chess, machines have become better qualitative players. So you have Deep Fritz and the current programs working actually as well as Deep Blue, despite the fact that they're about 100 times slower, because they're doing a better job of pattern recognition. So we are making steady progress on that, and that is really the key issue now. And part of the guidance we'll get in terms of creating the templates of human-level pattern recognition is to actually understand how humans do it, which brings up the issue of reverse engineering the human brain. It wasn't long ago before people were saying, well, our intelligence is just below the level necessary to actually understand our own intelligence. But what we're finding is that as we're able to actually instrument the brain and see what's going on, and our ability to scan the human brain and to actually see the connections and the firings of neuronal connections and synapses is increasing, actually doubling every year, we are able to develop very detailed mathematical models of neurons and neuron clusters. Lloyd Watts and his colleagues have actually created a engineering of the whole acoustic area of the brain involving 12 different regions with a great deal of detail, have re-implemented that in software and submitted that to psychoacoustic tests, which performs very comparably to human auditory perception. If you follow all the exponential trends in computation, communication, brain scanning, exponentially growing knowledge of the human brain, it's, I think, conservative to say we will have reverse engineered the principles of operation of the human brain within a quarter century. And that will provide us more powerful biologically inspired methods for pattern recognition.
Okay, well, we've had several AI specialists on the radio show before, among them Rodney Brooks of MIT, the director of the Artificial Intelligence Laboratory. And I asked him a key question, and that is, well, how powerful are the MIT robots? And he was very proud to say that he's the godfather of the Mars rover, an advanced robot which actually wandered on the surface of Mars. But he was honest and said that his most advanced robots have the intelligence of a cockroach. In fact, cockroaches do it a lot better, he said. Cockroaches can scope out environments, see obstacles, boulders, maneuver around them, and they're quite good at this. And robots at Carnegie Mellon and Stanford, well, when they walk down the hall, it's lucky if they don't gouge out a piece of the wallpaper when they walk down the hallway. So how smart are our robots? Are our robots really so dumb that they are really insect level at the present time, barely able to understand chairs, tables, the ceiling, the roof, people maneuvering around the room? How smart are the robots today?
Well, robots and artificial intelligence in general are operating far below biological levels, both in terms of hardware and software. And I think it's worthwhile talking about both of those, but also to understand that we're making exponential progress in both of these realms. And exponential progress really sneaks up on you. And just to use an analogy, Kasparov played the best machines in the 1990 at chess, and they were pathetic, and he scoffed at them. And it was just inconceivable that they would ever reach his level. But they gradually got better. They're doubling in performance every year, gaining 40 chess points every year, and chess scale is exponential. And then they surpassed him, operating at or beyond his level by 1997. We'll see the same thing in other areas. And it's easy to lose sight of tremendous power of exponential growth. We are doubling computation at least every year, and we'll talk a little bit later about about the issue of Moore's law, but I believe that this phenomenon will continue past Moore's law into three-dimensional computing. And in terms of software, we're making exponential progress, as I mentioned, in understanding and reverse engineering the principles of operation of the human brain. There's a new brain scanning method now that's being developed, which will be available within a couple of years, that will actually be able to see individual nerve fibers firing in a cluster of thousands of neurons at very high resolution, very high resolution also in terms of time scale, which will really give us the means to reverse engineer those circuits. I mean, so far, we've been really unable to see what's going on. It's very hard to diagnose a circuit if you can't instrument it, but if you can put sensors on in the right place and see what's going on, it's very straightforward to reverse engineer. The human brain is created by a genome that doesn't have very much information in it. Even though the human brain itself appears to contain thousands of trillions of bytes, the genome only has about 12 million bytes of information to characterize the initial design of the brain, because there's a lot of random wiring in the way it's actually constructed, which then self-organizes to reflect its experience with the world. So the principles of operation are of a complexity that we can't understand, and that will provide us at least biologically inspired paradigms for the software of intelligence. And so the capabilities of all of these systems will improve quite steadily, and we will master different levels of biological intelligence. Ultimately, I believe within less than 3 decades, by 2029, these machines will be operating at human levels and will combine human levels of intelligence, the subtlety and suppleness of human pattern recognition, with some of the natural advantages of machines, most notable of which is the ability to instantly share knowledge.
Now let's talk a little bit about Moore's law, the doubling time you mentioned of 18 months for computers, meaning that at Christmas time, your computers are almost twice as powerful as they were the previous Christmas. Exponential growth in bacteria, for example, eventually seals off, otherwise bacteria would take over the entire planet Earth. And exponential factors do taper off because of external effects. Now, with Moore's law and computers, the engine driving Moore's law is ultraviolet etching technology, by which we can etch tinier and tinier transistors on a silicon wafer the size of your thumb. But eventually the transistors get so tiny, you hit the quantum theory. And at that point, you get short circuits. Leakage takes place. All hell breaks loose. And by 2020, all bets are off. The Intel, one of the senior engineers at Intel, admitted recently in a major paper that yes, they can see the end of the tunnel, and that is at a certain point it's going to be prohibitively difficult to etch silicon components that are tinier and tinier, and eventually you get leakage because you don't know where the electrons are. Some people have said let's make three-dimensional cubes. But the problem there is you have heat generation, enormous quantities of heat generated in three-dimensional cubes. So the question is, what happens after 2020 when all hell breaks loose and Silicon Valley becomes a rust belt?
Well, it's a key question, and to examine that, I've done a number of things. I have been an ardent student of technology trends. I've been measuring the actual power of different technologies for 25 years. I have a team of people doing that. One thing I did is put 49 famous computers over the last century, long before there was a Moore's law, on an exponential chart. And this exponential growth has been going on not just for Moore's law, but back through 5 different paradigms. Moore's law, the shrinking of transistors on a flat integrated circuit, was not the first, but the 5th paradigm to provide exponential growth to computing. And every time one paradigm ran out of steam, because as you correctly point out, every method of exponential growth eventually runs out of capacity. Rabbits in Australia eat up the vegetation and stop growing exponentially. They even reverse direction. Every time that happened, another paradigm came along and started another S-curve of exponential growth. They were shrinking vacuum tubes to make to continue exponential growth. Finally, they couldn't shrink them anymore and keep the vacuum. That paradigm ended. Transistors came along. And the next paradigm will be three-dimensional computing. We live in a three-dimensional world. Our brain's organized in three dimensions. Our brain, by the way, uses a very cumbersome, very slow electrochemical information processing method. That's 200 calculations per second. They're digitally controlled analog transactions, but they're roughly comparable to calculations. At least 10 million times slower than electronic circuits, but it gets its tremendous power from the fact that it's organized in three dimensions. Now, the brain itself is an existence proof of the feasibility of organizing circuits in three dimensions and dealing with the heat problem. I proposed three-dimensional computing as the sixth paradigm to replace Moore's law, which was the fifth paradigm in my book, The Age of Spiritual Machines, 4 years ago. It was considered a radical notion then. I would say it's much more of a mainstream expectation at this time. There's been tremendous progress in building working dimensional circuits over the last 4 years. It's been a steady flow of breakthroughs, including conceptual examinations of this thermal issue that you alluded to. And there are ways of designing the circuits in porous ways to deal with the heat issue. 1 watt of power, which would not generate that much heat, would be sufficient to emulate human brain capacity in a cube that would be very tiny. So the thermal issue is, in fact, a key challenge, but there's a lot of confidence that that's feasible. And we still have at least a dozen years to go. And what we've seen typically is when the end is in sight for a particular paradigm, it creates tremendous pressure in the R&D community to create the next paradigm. And we have a lot of advance warning this time. And already, in fact, just using conventional lithography and going to the third dimension, because after all, even conventional circuits have 14 or 15 layers of material, so they do have some three-dimensional capacity. And there's been successful efforts to build circuits with dozens and even up to 100 layers of circuitry just using conventional techniques. There are many different approaches. The most effective appears to be carbon nanotubes, which is what I had predicted in my book 4 years ago.
Okay, well, the heat problem, as you mentioned, is quite fierce. Engineers tell me that very soon, even cubicle computers will generate so much heat you can fry an egg on them. Let me ask you a question about the the top-down approach and the bottom-up approach. When we had Rodney Brooks on the radio, he said that there are two approaches to artificial intelligence, top-down and bottom-up. The top-down approach has dominated AI research for the last several decades, and the goal there is to have a CD-ROM with all the laws of common sense, all the laws of logic on it. You simply put the CD-ROM in a computer, and all of a sudden your computer says, I think, I am aware, I am conscious, okay, I'm alive. That's the top-down approach, which failed rather miserably. We know that there are hundreds of millions of lines of common sense. We can't put them on a CD-ROM. There's so many of them. The other one is the bottom-up approach, which follows nature, Mother Nature, allowing machines to learn like bugs, like infants, to bump into the environment. And that approach is like a neural network approach. So could you explain to us a little bit about neural network theory? And this, of course, means that our brain, in some sense, is not really a digital computer at all. That perhaps we were sort of misled over the last 50 years in terms of the successes of silicon, but the brain is really a neural network and not really a Turing machine at all. Could you elaborate?
Well, I've always been a strong advocate of what you're referring to as the bottom-up approach. As I mentioned earlier, the brain, the design of it, is characterized by only about 12 million bytes of compressed information in the genome. You might wonder, how could that be when the brain itself contains millions of times more information than that? And the way it works is the genome specifies a particular design, but in a particular region, the actual wiring of the connection is random within certain constraints. And we know that that's the case, having watched how that process unfolds, then there's actually kind of an evolutionary process where the connections that make the most sense in the environment survive, and it's actually twice as many connections in the newborn baby's brain as exist a year later. There's a lot of self-organization, and the brain has the capacity to interact with its environment, make sense of the environment, as well as make sense of its own design and its own interconnections actually continually being repruned and reconnected to make sense of the environment and to learn. And that is really the only approach that's going to work. I think the Psych project of Doug Lynott is interesting. It's accomplished a lot, but I never felt that we could build human-level intelligence that way. We really have to build it the way nature builds it, which is a machine that has the capacity to learn, and then provide for its education. Now, neural nets is sort of one attempt based on a crude model of how human neurons work, which actually builds lots of neuron simulators and connects them somewhat the way the brain connects them and let them self-organize. And there's a number of different approaches to neural nets. They're all very simplified from what we now know is true of actual neurons. And as progress in reverse engineering the human brain progresses and we have more sophisticated and realistic models of actual neurons, we can build more realistic biologically inspired paradigms. But in general, pattern recognition, which is my field, works by emulating nature in these self-organizing methods. We set up some approach, which could be a neural net. There's things called Markov models, which is a mathematical cousin of neural nets. There are evolutionary algorithms that actually emulate evolution. And actually part of human learning has a kind of an evolutionary process take place inside the brain for the better connections that survive. And we use these techniques in our pattern recognition approach. We'll actually simulate evolution, have different solutions to a problem, compete with each other through thousands of generations of simulated evolution. And these biologically inspired methods are very powerful. They give results that are essentially unpredictable, just as sort of human decision-making is unpredictable without actually letting it unfold. And this is really the approach that will work, trying to define as analytic, logical rules every bit of common sense. It's not going to work. It's too complex, too unwieldy, and it's not how human intelligence works.
Well, I'll have to agree with Ray here. That is, we have a long ways to go before humans are surpassed by robots. Now, that's not to say that it's not going to happen. However, it could happen perhaps, I don't know, perhaps late in this century. And if you get a copy of some of my books, you'll start to understand my own personal point of view, that perhaps by the end of this century, robots could rival human intelligence and might even be dangerous. At that point, we should put a chip in their brain to perhaps shut them off if they have murderous thoughts. So we humans have to be in charge, because of course we don't want to be replaced by our evolutionary successors, the robots. We want to make sure that humans are still in charge. But if you want to know more, once again, get a copy of some of my earlier books, such as The Physics of the Future, which has a whole chapter on artificial intelligence and the job market.